Good morning, guys. Morning, Sage.
Good morning.
All right, let's get started. Sage, do you want to go over these pull requests? You had a lot to say on 15.141.
Sure. Let me bring up the pad.
Yeah.
Everyone. All right. So 511, 518. Okay. All right. So this first one came in 15141. That basically puts all of the key transaction work in a work queue, whereas right now it's being done synchronously. I'm surprised that it helped, I guess. But I'm also concerned that this isn't the right direction to go with Blue Store. It's sort of the opposite of what the RTC run to completion branch is trying to do, where we try to do as much work as we can synchronously and avoid any context switches at all. So I think it's going to make more sense for fast storage like NVMe. In fact, in many cases, we'll probably be able to actually commit synchronously without doing any context switch in the OSD portion. So I think that's probably not the direction we want to go in. But Mark did some tests on, I guess we're going to talk about that, the KV finisher. So I think we'll probably go down that road for now. Let's see, there's one from Halmai on the async messenger that reduces write lock intention. I think this is motivated by the profile that Mark did last week. So that's encouraging. I can't remember if he included any performance results in there. Did you look? He posted some perf counters, but I didn't have any context, so I couldn't tell if it actually made any difference. But hopefully it did. So we should test that. Interestingly, it removes the synchronous encode path. So there was an option in async messenger that would actually, when you call send message, it would encode the message right then. And we ended up not doing that and instead doing the encode work in the worker thread because it improved performance, latency, so on. And he just removed that entirely. But just fine, I guess we're just not going back. I think that's probably the right choice. Simplify things. Let's see, there's a RocksDB thing that supports slice parts. This is just avoiding a memory copy when we have multiple buffers that are being passed into RocksDB. There's an interface that lets you actually do that instead of copying it into one contiguous buffer. So that's good. I think last time I looked at it, it wasn't complete yet. So I'm not sure if looks like it's probably ready now. So that probably needs to be tested. Let's see, there's some stuff that merged. We're using GCC intrinsics for byte swap. I think that is slightly faster in some cases. Let's see, there's a optimization manager and the Blue Store one that puts BlueFS in the middle of a hard disk device that got merged. We didn't really see a difference, but intuitively it should be better. So that's what every other file system does. Also, it just puts the journal in the middle of the disk, since on average the seek should be shorter. There are a couple other ones. There's the BlueFS sync write one that includes a bug fix for sync write option that we definitely need to merge, and then it also changes the option to true, which doesn't seem to make any difference that we can measure. So I think maybe I'll just drop that and leave it asynchronous until we show positive evidence. I guess that's on my plate. Let me put that on my list. Okay, what's this? There's a pull request that simplifies the locking. After more discussion, we decided that's probably slower, so we're not going to merge that. Certainly not in its current form. There's lots of discussion around the CRC calculation of zero buffers. I haven't been following that discussion, so I'm not sure what state it's in. Maybe someone can chime in. Does anybody know offhand where that's at? Anyway, yeah, whenever we decide it's ready, it's fine, we can merge it, but I haven't been following the discussion, so I'm not sure. And then I had a pull request for Blue Restore that tries to change it so that the blobs that get marked unshareable or shared and immutable as a result of the cloning for the rollback for erasure coding. When that rollback information gets retired, then it tries to unshare the blob so that it can be modified again, basically. But it failed in QA, so I need to debug it and fix it. And that's all that stuff. Let's see, there's other stuff. There's 13996, which I think is pretty encouraging. When the last time I put it through QA, I saw a bunch of failures, so I couldn't explain it, so I pulled it out. So I need to go back and retest it and see if it is that pull request fault or not. I suspect it is. Let's see. There's a discard method. I'm hesitant to merge that until we actually have some evidence that it helps. The adaptive throttle, I'm not sure if we're going to merge that or not. We have sort of a really simple throttle in there now. I think, wait, where did we end up? Where did we land on the throttle? Do you remember, Mark? What are we doing?
Let's see. I think
we just tuned it for hard disk and SSD, right?
Yeah, but so then I think did we need to redo it? I think I don't know if we changed the default again or not, or if we actually ended up.
I think you had a second test that adjusted the config a little bit, but I think it was pretty close, if I remember correctly.
Yeah. But it might. Let me take a look at that, because we might need to actually change the cost value again. I don't know if we did or not.
Okay.
But yeah, it's.
Okay. Yeah, maybe just double check. But I think we're mostly okay there.
Yeah.
It might be worth coming back a little bit later and looking at if the adaptive throttle makes any further improvement. But I kind of doubt it is. The throttling doesn't really improve. It can only hurt mostly. It's just a matter of managing the queued up so that the QoS stuff will work better.
Mm-hmm.
Which makes it kind of hard to test, I guess, but so it is. Let's see, there's a pull request that changes the compressed block cache. Basically, a separate tunable for the cache for compressed blocks if you happen to disable or enable compression, which we don't by default. So I think we can merge that in case somebody changes. I don't know. In case somebody enables compression in RocksDB, then we can do it. But in general, it doesn't help. Compression usually makes it slower. So
I'm a little concerned that we have the normal block hash, the compressed block hash, then we have all of our caches on the BlueFS and BlueStore side. It seems like we're kind of all this is becoming somewhat redundant.
Yeah. And we could instead just make it so that it sets the compressed cache the same size as the regular cache. So it's either on or off, and it's going to be one or the other, presumably. But I don't know.
One of the things that really is weird, which I don't understand, and maybe it's just, I think maybe they're going to change it, but it doesn't seem like the block hash and the compressed block hash actually help you in compaction. Like you're not doing reads from cache, you're always doing reads from the SST files. And now that we're doing like the read ahead, it's way better. It's not nearly as much of a big deal as it used to be, but it looks like we are never hitting the cache.
Yeah.
And that's where it seems like we need it.
Yep. Yeah, I don't know. Okay. Well, I think we can let that sit for the moment.
Sure.
Let's see. There's the kvsync thread pull request that Igor is going to rebase. He's going to drop the additional commits that cause the deadlock and merge the simple version. It seems to help. We'll talk about that in a minute. Yeah, there's a bunch of other stale stuff here. Still hoping that Radislav can resurrect the stuff that he was doing with in BlueStore a while back, but he's still finishing up the Redis gateway pieces, I think. The BlueFS write cache is still buggy. I think it's not really critical for Luminous because you can just turn on the option to use the operating system's page cache, so it's not really needed. Just like to get away from that eventually. And I guess that's it. There's still the BlueStore, so 12062, which is with BlueStore RTC, the run to completion stuff, sync commit transaction. That I think that needs, well, it needs to be rebased. It was mostly complete as far as it went, at least. I think probably what we really need to do is try that out on either an NVDIM or an NVMe for the journal and just demonstrate that it actually helps. And if that's the case, then we should merge it. But until we actually show that it helps, it adds a little bit of complexity to those paths, and there's a little bit of risk associated with it. So, yeah, I guess that's it.
Sage, I wanted to ask you about 11.621. That's down second from the last.
Mm-hmm. Yep. I think we want to do this eventually. I think there are a bunch of places where we could benefit from using the slab containers because we have containers that are almost always small, like sets and maps that only have a few items.
Yeah.
But it needs some like careful. Patches need to be cleaned up. The code needs to be like carefully gone over by somebody who is savvy with all the C++11 language features and make sure it's sort of the best we can make it.
So that particular PR, you think probably needs a pretty big review?
Yeah, I mean, basically it lifts the code, lift the useful bits of the code out, and like probably make a fresh patch out of that.
Okay.
I think, and clean it up. Yeah. Yep.
Cool.
And ideally, what we would do is do that and then use it in a few select places and then show that it helps. Right.
Is that something that could be looked at kind of simultaneously with the OSD work that's coming up?
Yeah, definitely. Yeah. This is a pretty fine-grained optimization, I think. And probably the places where I would put it first would be in BlueStore in the trans context. There are a whole bunch of containers. There are like a zillion sets that we're doing that usually have like one or two items. And also in the OSD, there's a new PG transaction abstraction that sort of abstracts away the details of erasure coded versus replicated pools when you're building a transaction, and that has a whole bunch of sets and lists and maps. And they're usually small because there's usually only one IO. So that would also probably benefit.
Yeah, when we talk about this profile later on here, there's a lot of big things that are showing up, but some of the stuff that's not really showing up in this is dealing with all that kind of stuff, which it seems like is kind of scattered all over, but I kind of wonder if maybe it's bigger than it looks like when you just stare at one of these things.
Yeah. Yep. Yeah, I think the allocator is the impact of the load on the allocator is kind of hard to measure.
Yeah.
But, okay. Anyway, should we talk about the KV finisher?
Sure. So beyond what I have here, I mean, it's not that much to talk about yet, I guess. Igor kind of reminded me that he was seeing really big improvements with this a couple of weeks, or maybe it was even a month ago. I've been meaning to look at it and just haven't yet, but finally this week I was able to. And yeah, for 4K random writes on one OSD using a client running FIO with the librd backend, it was pretty dramatic. It was like we went from like 25K IOPS on an NVMe up to kind of fluctuating between about 30 to 40K. So it was a nice bonus, nice bump. I did do a wall clock profile while testing it, and yeah, we're spreading work out much better than we did previously, but both the bstore KV final thread and bstore KV sync thread are quite busy. They're not as bad as it used to be, like I said, but there's a lot of work going on. So yeah, there's a profile there for anyone that wants to look at it. I kind of tried to go through and look at stuff that seemed to jump out at me that looked kind of interesting. Let's see.
Still 20% on the async messenger write lock.
Yep.
I'd be curious how mice patch on top of what you tested theirs.
That's it. Yeah, that's exactly what I was thinking too. That was timely of him. I was surprised that we're actually hitting the PG lock at all for random writes like this. That's kind of crazy.
Yeah. It's not too much time.
It's not, but it's the big thing here is that this should be like an ideal workload for it, right? I mean, it's just scattering stuff all over the place for like sequential writes.
1% is pretty scattered. Like if you randomly do it, you're still gonna collide a few IOs.
Yeah. For sequential writes, of course, it's really, really big. What else?
The op trackers, like 10.5%.
Yeah, in that thread anyway. Well, this Blue Rocks writable file append. I don't remember. I should go open it back up and look at that again, but that was a lot.
That's where it's actually writing.
Yeah. Okay.
So it's waiting on the device.
Sure.
Too surprising.
Well, that's not bad at all then. That's good news. That's spending a fair amount of his time there. This RocksDB memtable key comparator is now really big.
Mm-hmm. Those there are big memtables.
Yep. So your idea to allow us to shrink everything down while not overwriting stuff into level 0 would be good. I think that's becoming more important.
Yeah, I wish I remembered. There was Tushar at Intel said that at OpenStack last week. He said he has somebody who's going to be looking at the RocksDB piece, including that. I can't remember if he mentioned a name. So that's good news.
Yes, very cool.
All right.
Yeah. Otherwise, bufferless rebuilds and rebuild the line size and memory is showing up. There's other places where it does too, but
that is, oh, I bet that's because the compaction buffers that are being generated by RocksDB aren't page aligned. I bet that's what's going on.
okay.
Because BG0, that's the compaction thread, right?
BG0, yep, is a compaction thread, and then we've got the other thing down in bstore KV sync. 6247.6.
Okay. All right.
Yep.
Any
So
other topics people want to cover?
Hiya, Nick here.
Hey.
So just I was talking to Mark last week about the deferred write stuff. So I just gave it another quick test with the latest master, and it seems pretty much to be the same sort of performance now as file store. The disk definitely sort of in the same utilization as before, so that looks like it's sort of working now. So that's
excellent.
Good.
That's good news. Thanks for confirming.
Hopefully, I'm just waiting on some more NVMEs for our next batch of nodes, but there's a bit of a SSD drought at the moment, so I don't know when they're going to turn up, but I should be able to run that on our hardware before they go into production to see if they can hit the same extreme low latency we were getting. So this test I've done so far has just been on the test box.
Mm-hmm.
But yeah, I thought I'd just report that back.
Awesome. Cool.
Hello, Sage. I'm Sam from Alibaba. So we submit a pull request for execute the Q transaction asynchronously in some thread pro at the object store there. You comment that, so you said it's kind of disagree with your the direction of optimization. Basically, it's adding more context switch, more threads. But we saw some problems like currently the PG worker, it has a long function path, basically doing a lot of work, and the PG lock is held while doing this. If there are some other IO target on the same PG, basically they are blocked, they are serialized. So we are thinking either way, we add another thread flow to split some function which does not rely on the PG lock, so we can do this in pipeline. So some part of function is doing in the PG worker, some part of the function is doing in the other threads. So we can basically make the request going in pipeline, different requests which target on the same PG goes pipeline. So in the we have some slides basically show the performance, especially for sequential write, because sequential write since the object size,
okay.
So do you think that makes sense, or do we have other plans like to reduce the PG lock granularity? Something like that may also help, basically.
To think about it a little bit more. I'm not sure. So I didn't actually look at the code here. I just read the description. But the main correctness issue is that when you queue the transaction, you have to be holding the PG lock in order to preserve the ordering.
Yes.
So
after we get the sequence, basically the sequence number, then we release the lock.
Got it. Okay. So that part's correct. So I think that makes sense. My intuition says that probably the best approach in that case, if we go down this road, would be for not necessarily to pass it up to another thread, because that introduces a context switch, but to instead take a second lock, like a PGIO lock or something, and then drop the first lock. So you don't do a context switch, but you release the lock, because then you should get the locking benefit, so you can pipeline you start the next request.
Okay, I see. So
but
another,
I'm a little bit nervous about making this more complex right now, because we're about to restructure a whole bunch of this code in the OSD as soon as Luminous is out. I'm not sure that this is the time to do it, I guess.
Okay.
So it's I mean, it's encouraging that this works for sequential IOs. And that's like a helpful data point to make sure that what we build is going to can accommodate that. But I don't want to complicate the walking right now.
Okay, so thank you. So I have another question. So basically, in our performance profiling, we find that for BlueStore, the IO pad, the metadata synchronized, that latency is much higher than the data IO weight. So do you think is it better to submit the RocksDB sync in the individual worker thread instead of just using one K thread to do a batch sync?
Yes, possibly. So that's exactly what the BlueStore RTC branch does. Let me find the pull request that does that really quick, so you can look at it. I think it might need to get rebased. I haven't looked at it recently. Yeah, it needs a rebase, but it's probably not too far off. I'll put it in the chat. So that's roughly what this pull request tries to do. So it makes it so that you can either queue the transaction synchronously, or you can actually commit it synchronously, where you wait for the IO to complete from the worker thread. There are a whole bunch of sort of restrictions on when it's safe to do that, because you have to preserve the ordering of IOs and commits within your sequencer. But all that infrastructure is in that pull request. So I think that's roughly the right way to go. There are a few commits towards the end that try to also make it so that you can do the IO completion callback synchronously also. Those aren't very well tested, and I'm not sure if that's sort of the right way to go. So you could just ignore those for the time being and focus just on the front half of the patch series. Yeah.
Okay.
Feel free to take a look.
Okay.
This is based on work that somebody else submitted. I can't remember his name. Voidbag, I think is his username. So I took those patches. Yeah, he's commenting on the pull requests and cleaned them up. But it needs them. So this is actually, I mentioned this a little bit earlier when I was talking to Mark. I think we need to, if we can rebase this and demonstrate that it actually is improves things when you have an NVMe or an NVDIM for a journal, then I think it's worth merging, at least the first part of this PR. But we should just sort of do that testing to make sure it actually is making a difference, because it does add a little bit of complexity. So if you guys want to test it out, that'd be helpful. Or see if it, yeah. Does that make sense?
Yes, thank you. Thank you, Seth.
Thank you. Okay. Okay. Anything else?
Good morning. This is Mohammed.
Hey, yep. How's it going?
Good, and you?
Pretty good.
I just Two small things I wanted to mention. The first one, I don't know if this is considered as performance, but I submitted the PR for the instrument functions flag sometime last week.
Instrument functions, which PR is it?
Let me just find it.
Oh, the dash Ceph instrument functions.
Yeah.
Yes. Yeah. Okay. Yeah, I just wasn't sure what this does, and if we wanted to do it, I guess I wasn't sure. Oh, just
okay.
as a CMake option. I see. Okay.
Yeah, exactly. Yeah, I didn't mention it, but this was regarding my email that I sent to Ceph Devel for the tracing stuff.
Right. I think we actually asked you if you could do this. So yes. Okay.
Yeah. So obviously, it might not be the time because we're releasing Luminous, but I just wanted to point it out.
Yeah, I don't think there's any reason not to do it as long as it builds. This is just adding a CMake option that compiles it in, and it's off by default, right?
Yeah, and also a C file that will implement the extra functions generated by the compiler.
I see. Yeah. What does -pi normally do?
It changes I think it randomizes the addresses of the functions at one time.
That's a security thing.
Yeah.
Yeah, this looks good to me. I think probably we should get one of the CMake people to look at it. So let me ping Amar.
Yeah, sure. And there's also something I'm not too happy about is that I hard coded the functions that are inline in source OSD CMake list .txt at line 7. As far as I know, I didn't find any other way to avoid adding that flag. So if someone has any idea.
Wait, say that again.
So on the source OSD CMake list.txt, and whatever I added at line 7, I have instrument functions exclude function list equals.
Oh, I see.
Because these are functions inline, and
oh, I see.
So the compiler tries to add the extra function call at the beginning and end, but they're inline, so the linker causes problem.
Yeah, that seems fine. I don't think it matters too much. Cool. Okay.
Great, thank you. And the other thing that I wanted to ask was regarding Bilkin. I just wanted to ask about the status of it because I tried to run it. On my setup, at least, I cannot see any trace points from Bilkin, and I think it breaks the trace points that are already there with the LTTNG. It might just be through my setup, but yeah.
So the block-in, we merged the Rados block-in patch, and it but it's disabled by default. You did CMake, you turned it on.
Yep.
Yeah. And I don't know. I was harassing I can't remember if it was Casey or Ollie to update there's a document that's just like a how to use it because when I followed the directions they didn't work. So I'm not entirely sure what the status is there.
Sure, no problem. I'm happy to investigate further. I just wanted to see if there are any known issues. Thank you.
Okay. Cool. Yeah, there is. So the Rados block-in one merged. There's a second patch that adds all the instrumentation to RBD. Also, that's a cleaned up version of the original that Jason just posted, I think earlier this week. So that should probably go in shortly. But yeah, I think that the doc needs to be updated because I don't know. Don't know how it works. Okay. Kestrels, do you want to go? You're muted, I think. Can't hear you. Yeah, click the button.
Hello, can you hear me?
Yes, yeah, that's better.
Okay. So the question I had was for Peter about the improved CRC calculation for zero buffers on line 48 of the Etherpad. I know we've been discussing the crossover point for very, very small buffers where it doesn't make sense to use the fast zero optimization. But other than that, it seems like he's incorporated most of the comments. I just wondered what remains to be done on that request, and if it's related to the crossover point, then I can try to help with that or do more testing. But that seems like kind of a nit, and I wondered what his opinion was.
Can you hear me?
Mm-hmm.
Okay,
yep.
So this crossover point is pretty much a thing we can't agree on. I think it should be set at 2 kilobytes or 4 kilobytes because this is the size of the data structures used by Adam's CRC code, and this is pretty much a decent point at which his code outperformed existing Intel CRC calculation code.
Okay.
This is
But I guess what I'm
from my side.
That's the only thing holding it up, really, or?
That's everything from my side. I think it needs to get through the tautology testing, and and if it passes that, then I don't see why it shouldn't be met.
So if the PR is ready, if the crossover is already in the code, is it already in the branch?
No, he's being a bit stubborn about changing that one point, and I guess my point was the rest of the code looks like a significant improvement, and if somebody changes that one line, then Peter would get. I mean, I agree with Peter about the crossover point, and I tried to put data in the PR to back that up. I don't know why Adam doesn't agree, but I guess if that's a one-liner that's wrong, we could always change it later. But even with that line being wrong, it's significantly better than the code that's in the repo today.
Yeah. Well, this is 11966. Is that right? Improved calculation for zero buffers.
Let me look.
Yeah.
It looks like line 28 of CRC 32C.H. There's all this discussion between us about.
Oh yeah.
He's got
16. Oh, and it should be 2K. You think?
Right.
Got it. Yeah. Okay. I'll just mark this needs QA. We can just make sure it makes it through the suite. It's probably fine to do it this way anyway for QA because we'll get good coverage on both sides of the threshold. But yeah, we can switch it after the fact or whatever. Either way, I have no opinion on the threshold. Okay. Cool. And I noticed that you referenced the PowerPC 64 fast zero also. Oh, this is your pull request. I see.
Yeah. So that one is I marked it do not merge this morning because I need to do a little more on it. But in general, so on x86, my findings were that. Sorry, let me back up. When I first put up the pull request, the only reason I was putting it up was because Adam's code falls back to the optimized assembly in this one corner case. And since his code was faster than all the other versions on x86 and PowerPC, I was really only putting it up for that one corner case as a fallback mechanism. And then when Peter pointed out this problem about it does a bit reversal on the way in and on the way out, and the code for the bit reversal was kind of brain dead and not a very optimized loop, and it was turns out really slowing things down. And so when I replaced that with some code that was already in another part of Ceph that does almost the same exact thing, it changed my conclusions. And so Adam's code is faster on x86, and then this PPC64LE optimized assembly is faster on PowerPC for the FAT0 case.
Mm-hmm. Okay.
So,
okay. All right. Well, we'll wait for the first one to merge first, I guess. This will go on top.
Right. Yeah. Sorry. I mean, he got there first and all of that, and so having him merge first is certainly fine. I just, what was I going to say? I put a lot of side things up on the repo that I linked from the pull request of trying to back up my findings with data. I don't know if Peter's looked at that or if that's too much, but anyway.
Okay.
Sorry, I have a lot of work at the moment, so I can't focus at everything at once. Sorry. I will take a look at
I don't blame you. No problem.
Cool. Okay. Sounds good. Are there any other sort of outstanding issues on the PowerPC front that are on your radar? Besides
No,
CRCs?
I think so. The other one is more for the RocksDB folks, right? So when you move to BlueStore, there's also a CRC algorithm in BlueStore. We're going to upstream there, but I don't think you're worried about that one.
Yeah, I mean, as soon as it goes upstream of RocksDB, we'll just pull it in.
Great.
Update.
So those are the only ones on my horizon.
Or in RocksDB. Yeah. Okay. What about the on the erasure code front? Is the JErasure code isn't PowerPC friendly, right? It's all Intel specific.
Right. So the JErasure code is not optimized for PowerPC, and I don't think it will be anytime soon. I think we were looking to have ISA-L be the vehicle for PowerPC.
Oh, that's right. Okay.
But
okay.
That one's taking a bit longer, and I has a bit more technical debt to it. So I don't think you'll be seeing that within the next month or so.
Yeah. Okay. There's no rush there, I guess. Okay. Yeah. The thing to keep in mind is that the ISA-L library isn't byte compatible with the JErasure. So if it is added support into ISA-L, then you could use that plugin, but you would be restricted to Intel and PowerPC, and you wouldn't be able to mix in ARM.
Okay.
There is another library that is called GF-Erasure, I think it is. That's a candidate to replace JErasure. That might be a place, but yeah, that's a little bit early, so I'll share more when that develops a bit more.
Okay.
Okay. Cool. Anything else? All right. Sounds good. Everyone, have a good Thursday.
See you guys.
Thank you. Goodbye.